Okay, this last example is going to have some messy fractions in it, but I'm going to show you how to get rid of those fractions before you start the problem. And I actually saw somebody do this on their homework from chapter 2, and I was like, oh, I completely forgot about that trick. I should probably teach that. I usually have to work with fractions in calculus pretty extensively, so I don't use the shortcut tricks as much. And so sometimes I don't remember that they are available to us. Okay. So again, this works with regular solving equations. Do not have to wait till you get to system of equations to do this. But anytime I have an equation with a bunch of fractions in it, if I can find the smallest number that all three of these divide into, that's called the least common multiple, I can multiply that equation by that number and get rid of all the fractions, every single one of them. So if I have 3, 4, and 6, the smallest number that all three of them can divide into, which is called a least common multiple, is 12. So if I multiply this entire equation by 12, all of the fractions go away. Same thing for this one. I've got a 2 on the bottom and a 3 on the bottom. So my least common multiple is 6. So if I multiply everything times a 6, the fractions go away. Now I can't promise that something's going to eliminate here. You still may have to multiply by other numbers for the elimination process, but this will definitely get rid of every single fraction in the whole problem. So 12 times 1/3 is 4x. 12 times 1/4 is 3y, and 7/6 times 12 is actually going to be 14. And then 3/2 times 6 is going to be 9. 1/3 times 6 is 2. And then 7/3 times 6 is also going to be 14. So again, that didn't create a situation where it's going to eliminate. Okay, now we have to multiply by more numbers to get this stuff to eliminate. And again, this is one of those situations where, there's not a quick fix for this. There's nothing I can multiply here to match these, and there's nothing I can multiply here to match those. So we're going to have to do both. Now, what's convenient is these two are already plus and minus. So I'm going to work on my y's so that I don't have to worry about multiplying a negative. Okay, remember when we do this process, I'm going to take the 2, and this equation is going to get multiplied by 2. I'm going to take the 3, and this equation is going to get multiplied by 3. Remember to multiply all the way in. So that gives me 8x plus 6y equals 28. And 27 minus 6y equals, I don't know what 14 times 3 is. 42. Our 6's cancel. 8 plus 27 is 35. And that equals 70. So I can divide by 35, which happens to be half of 70. So that's going to give us 2. Again, I can put this into any equation, not just the beginning ones. I can start with this one, or I can do that one. It doesn't matter. I'm going to use this one. 4 times 2. Remember, this was the x. 3y equals 14. 14 minus 8, 6, and y also happens to be 2. And there you go. That's about the messiest, craziest one I'll give you, except for a decimal one that I'm going to let you figure out on your own. Cool, cool.